This is the winter 2016 end of quarter wrap up for physical games with a purpose. One thing we really looked into this quarter was what our motivation and what our research questions should be. We want to be able to entice users to interact with their physical environment to help create data, but we want to do that through leveraging the affordance of the everyday objects. As you're walking around, there are trees. Trees afford bumping off of. They afford jumping to their branches of. Benches afford standing on. Benches afford sitting on. How can we use these different affordances to create fun games that not just allow us to collect data, but actually create a sense of wonder and excitement and cause users to look at the world around them in a way that they might not have considered otherwise. And once we are able to figure out how to create these games and experiences, our end goal is to create a framework that allows anyone to be able to build these games and allow for an easy way to create these physical games that are able to collect data.
So the goal for this quarter was to create a system that curates tasks for user based on the user's immediate location. The goal was for these tasks to be fun and enjoyable and allow for physical interaction that would otherwise not take place. To do this, we created a system architecture that allows for the curation of object-specific games. So here's a simple diagram that shows how the system works. In our world database, we have 3 tables. We have a table of audio tasks that instruct a user to complete an action. We also have a table of object mappings that tie objects, such as benches, to the real-world coordinates. We then have a final table that ties audio tasks, such as a task requiring a person to duck behind a tall object, to an object, such as a tree in this case. So when a user begins playing the application, their location is noted in the system. That location is used to see if there are any objects near the user. If there are any objects nearby, the system checks if there are any unplayed tasks associated to that object. If there are, the game is triggered, and the user completes the task. This process continues until the user wishes to exit the app. So the following clip is a demo of our physical game for the purpose system in action.
Barley's crew has covered the crosswalk up ahead with fine powder that can collect footprint data. To avoid being trapped, only walk on the white painted crosswalk line. You're passing over a manhole cover that leads to one of our underground vehicles. Stop 3 times in the cover to let our team know you're passing overhead in case they need you to collect above ground intel. Great work, comrade.
Yeah.
Barley's team has sent you to one of our underground bases. I bet you can see the corners of the sidewalk. Sit over that.
So for this project, we conducted multiple studies to gain user and system feedback, with our final user test being the most valuable. Our end of the quarter user test consisted of testing our immersive gaming prototype on 8 users. This prototype allowed for users to be presented physical space tasks that took advantage of the objects near their location. This application was wrapped in a spy thriller motif, revolving around completing tasks to earn favor as top spy. From our user test, we gained valuable feedback on our system and playability. We then aggregated that feedback into some common takeaways, which I'll talk about right now. So we found that generally the most important or well-liked part of the test was the exploration aspect, not necessarily the theme. Consistent feedback was that users enjoyed the overall motif of having to explore their surroundings. However, it was common for users not to even remember the dialogue or why they were doing actions in the game, even if they remember the actual actions. In addition, a question has always been, how often can we ask a user to complete a task without actually burdening the user? And we saw that generally users wanted to complete many tasks at the beginning of the game in order to get into the atmosphere of play. Tests in which it took a long time for a user to get a steady stream of games felt less excited to play, especially at the beginning of the game. So we also saw that testers felt games were more enjoyable the more unique the task was to their situation. Games that were more general and could be played anywhere were not as fun as other games, even if they were simpler to do. So for example, games that triggered at precise locations, such as when there was a crack on the sidewalk, was novel because it was clear the app knew about the user's location and their surroundings. But a task that triggered by the presence of a tree was less exciting because there are almost always trees nearby a person. So this takeaway was pretty interesting. When we user tested in groups, testers often aggregated to certain locations in the beginning, ending up near each other for quite some time. We saw that when testers played the experience with other people or near other people, the testers felt more comfortable completing some of the more outlandish tasks, and overall felt the experience was more enjoyable. But it should be noted that, however, the collaboration was not required to complete the tasks. There were many users that completed all the tasks, no matter how outlandish they were, even if they were by themselves. So from our user test and from our general research throughout the quarter, there were a lot of things that we found that worked and a lot of things that we found that didn't work. So one thing that really did work, especially in the user test, was the user test seemed to prove the concept of playable experiences that take advantage of physical space. User testers enjoyed engaging with their physical surroundings as well as the new perspective they gained through this new form of play. Sometimes the interactions with the physical world came from coincidence even. For example, when a user went to look for a note on a bike rack, they actually did find a note that just happened to be there. And those types of validations, whether they be from the game or coincidental, with the real world in the application, excited the user and kept the user really engaged. Using affordances also seemed to enhance gameplay and allow for more immersive, enjoyable experiences by the user. By knowing what an object can do, we were able to create tasks that were very specific to certain objects, and that uniqueness improved gameplay and enjoyability. However, there were also a lot of things that didn't really work, either in our study or from our research, that we will definitely have to improve on in the future. So the self-contained nature of each task was one thing that didn't really work too well in the user tests. Users wished that they had more feedback from one task to the next, and wished their actions had more or any actually influence on the experience. For example, positive reinforcement when actions were completed correctly, or even past actions and tasks affecting a user's upcoming tasks. Users also wished there was more of a story with accomplishment and ending. It was generally a big middle in the middle section of the application. Moreover, the use of scoring didn't seem to influence user motivation, but that might have just been an issue of implementation that we'll have to check on possibly next quarter. And in addition, some technical issues plagued the user tests, such as games not queuing up correctly, but overall, this was not detrimental to the testing, nor to the experience.
As we're looking to next quarter, we're thinking about ways in which we can improve the user experience through collecting data and being able to use that data collection to affect the user's experience live while they're doing it. So before a user is prompted with a task or a game to complete, right now they're just prompted with one wherever they happen to be. But how can we guarantee that that action is along the path that they are currently walking? So we're looking into pre-tracking to potentially see how we can do this. And then when a user is performing a game action, how can we be actually storing that data? Whether that's geographical data or motion sensing data from their phone. And once we have that data, how can we potentially use machine learning algorithms or work with habit sourcing and some of the work they're doing on collecting data and process that data to actually extract meaningful information from it? And what is that meaningful information we will be extracting, and how can we use that? And then once a user has completed a game action, how can we give them feedback so that they know they've completed the action correctly and the app has sensed it? Right now, they just get a good job audio feedback no matter what, like 10 seconds after they are told to do the task. And we're thinking about more interesting ways about what feedback could look like when they go to a center of the field where they're supposed to be able to receive a package. Can they actually have on their phone a picture of a package appear? Just one example, but a way to let a user know that we are aware of what they are doing and they have done so either correctly or incorrectly. And then after a user completes one task, how do these tasks build on each other? Or should they not build on each other? How can a user progress through a game, and what does that progress look like? For examples of this, we're looking at WarriorWare, which is a Wii game that's just a series of mini games that don't necessarily relate to each other, but yet the game still has like a beginning, middle, and end. So looking at how they were able to achieve that. And also games like Journey that don't really have a start, but just have a middle and an end. And thinking about what direction we want to go in terms of our game progress and design overall. Outside of specific design goals that relate to our tech, we also want to create a framework that would allow anyone to create a game. And so the idea would be you have this cool game idea you want to create, and you can use our database of game parameters to set some parameters. This game should be played when it's sunny and you're by a tree and there is a rock nearby. And then this is the game you should play, and here's the story. And then once we have the ability to easily create mini games, we can have a whole database of these mini games. And then how can we have, when a user's walking around, more advanced user conditions that allow them to trigger these mini games appropriately? And once those mini games are triggered and played, how can we collect that data and send that data back in? Right now, in order to play a game, we have to have a pre-mapped out that there's an object there. One of our other end goals is how can we find out where objects are through user play? So a user could play and tell us where a bunch more trees are. And now that the user has told us where those trees are, we can use those other trees to give games to other users. So it's kind of a feedback loop that builds on itself.